Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 13.2. Problem number 1. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. So find the volume of the solid in terms of pi. So here the given parameters are, we are having two different shapes, right? So here one is a cone and another one is a hemisphere, and you see the cone is standing on the hemisphere, right? So here you see, here we have a cone and this cone stands on a hemisphere, right? So here what about the radii? Here the radius is 1 centimeter with both their radii, right? So the radius of the hemisphere as well as the radius of the cone is 1 centimeter, and again height of the cone is equal to its radius. So what about the radius of the cone? It is 1, right? So radius is equal to height. So obviously the value of height of the cone is 1, right? Find the volume of solid in terms of pi. So here you have to find the volume. So what is the formula for volume? So they had given, right, you see, in terms of pi, okay? So just you can keep pi as such, okay? No need to substitute its value. So here the volume of the hemisphere is given by, it is 2 by 3 pi r cube. So what about the radius of the hemisphere? It is 1. So just substitute 1, and so here the answer is 2 by 3 pi centimeter cube, right? Because you see the radius is given in centimeter. So here comes centimeter cube. The next one is volume of the cone. So volume of the cone is given by the formula 1 by 3 pi r square h. Again the value of r is 1 and again the h is also equal to 1, right? So here again we will be having 1 by 3 pi centimeter cube, right? So now we want the volume of the solid. So volume of the solid is, you have to add the volume of cone plus the volume of the hemisphere. So when you add, right, so here the volume of the hemisphere, it is 2 by 3 pi, and volume of the cone is, it is 1 by 3 pi, right? So since both the denominators are same, we can add the numerators. That is 2 pi plus pi gives 3 pi. So 3 pi by 3, again this 3 and 3 will cancel, and finally the answer is pi centimeter cube, right? Problem number 2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet, right? So here you see, what are all the shapes here? We have a cylinder, right, with two cones. And these two cones, how they are attached? They are attached at the ends of the cylinder, right? The next thing is, the diameter of the model is 3 centimeter and its length is 12. If each cone has a height of 2, find the volume of the air contained in the model that Rachel made, right? So here we are having a cylinder, and on both the ends of the cylinder we have two cones attached to it, right? And the parameters are given here. So here you see, okay, this is the cylinder, right? This is the cylinder and we have cones attached on both the ends of the cylinder. So what are all the given parameters? You see the diameter of the model, right? So the diameter of the model, it is given as 3 centimeter and the length is 12 centimeters, right? So here the length is, the entire length is 12, and the height of the cone, right, here it is 2 centimeters. Similarly, the height of this cone will be also equal to 2 centimeter, right? So we need to find the volume, okay, volume of this design. So obviously what will we do? We will calculate volume of all these three things, right? Volume of the upper cone, volume of the cylinder, and volume of the lower cone, right? That's it. So here the thing is, you have to know the formulas clearly. So what about the volume of the cone? It is, you see, 1 by 3 pi r square h. What is the volume of cylinder? It is pi r square h, and again volume of the lower cone is 1 by 3 pi r square h, right? So here you see, we are given with the diameters, right? The diameter of the cylinder is same as the diameter of the cone, right? You see, because obviously they are attached to one another. So here the diameter is, it is 3 centimeter. Then what about the radius? It is 3 by 2, which is 1.5 centimeters. Right. This radius is common for both the cylinders as well as the cones. Right. Now, the other criteria we have to discuss here is, we have to find the height of the cylinder. Right. Because height of the cone and radius of the cone are given. Right. That is, the diameter is given. Just now we have calculated the radius of the cone. So, how to calculate the height of this cylinder? Can you make any guess here? Yeah, I believe most of the people will be saying correctly. Here the total length is 12, right? And this height is 2 and this height is 2, right? So, height of the cylinder can be given as, so height of the cylinder is given by 12 minus this 2. Again, at the bottom you have to minus this 2, right? So, which is 12 minus 4. So, here it is equal to 8 centimeter. Right. So, we know all the parameters, right? We know the radius and height of the cone as well as radius and height of the cylinder. So, we can easily substitute it. So, here write it, height of cylinder. So, here just substitute. While substituting, you see, so the radius is, it is 1.5, right? So, 1.5 square and the height of the cone is 2. Similarly, here pi into radius is 1.5 and the height is 8, right? And here it is 1 by 3 pi r square h and the value of r is 1.5 and here the height is 2, right? So, you see both the cones are similar, right? So, this expression and this expression will be the same, right? So, anyway, you see here now I am taking the common parameters outside, right? So, while taking common parameters, you see, these two terms are same, but we have here another term, right? So, here I am taking, you see, 1.5 square, 1.5 square, 1.5 square. And the next thing is pi, okay? Pi is present in all the three expressions. So, again, here I am having 2 and here I am having 2, but here I am having 8, right? So, this 8 can be written as product of 2 into 4, right? So, from this I am taking these 2 outside. So, what about the remaining thing? The remaining thing will be 4 here, right? So, when I take all these terms outside, the remaining term in the first part is 1 by 3. And here when I take this 2 pi into 1.5 square, you see the remaining term here is 4, right? So, 4 and here again the same thing 1 by 3. So, the next step is we are substituting the values, right? So, 2 into 22 by 7, here the value of pi is not mentioned, right? So, you can take the value as 22 by 7 into 1.5 square into here when you take LCM, so the base is 3, denominator is 3. So, here it is 1, right? So, multiply by 3 on both sides. So, 4 3s are 12 and here it is 1 and here it is 1. So, again when you simplify, here we will be having 2 into 22 by 7 into 1.5 square into 14 by 3, and when you cancel the common terms, finally we will be ending up with the answer as 66 centimeter cube here, right? So, you solve and simplify, finally our answer is 66 centimeter cube, right? So, here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.